Welcome back, Math 3 folks. If you're choosing this video, then you have probably selected going over coordinate geometry, which is reviewing the distance formula, the midpoint, and how to graph or model something that has to do with a coordinate plane or coordinate geometry. So we're going to break this up in not layman's terms, but simpler terms, looking at Unit 2 and focusing on the coordinate geometry piece of this unit. And the first thing I want to do is talk about kind of our objectives. A lot of times you may have seen some of the videos in the past. I haven't really given you an objective for today or for these videos, and that's kind of inappropriate on my end because you don't have a tangible outcome other than just listening to me talk. And unless that's what you are desperately interested in doing, then you may find these videos kind of not helpful for you. So the first objective that I want us to do is to be able to calculate the distance between 2 points. That's one of the important pieces of coordinate geometry that you'll be tested on. And this is a huge component of just geometry and anything that has to do with graphing in general, being able to calculate the distance between 2 points. In addition, I want you to be able to calculate and find the midpoint between 2 points. What point is actually located in between two different points, and how do you actually find it? So the first one is looking at the distance between 2 points. Second one is looking at the midpoint between 2 points. And overall, I want you to be able to properly create an appropriate graph. And let's quickly define the word appropriate when it comes to graphing, because a lot of students can create a graph, right? You just go, huh, 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 huh. You put some lines there, you call it the x-axis, the y-axis, boom. And you say, this looks lovely, this looks excellent. No, 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 no. How do we create an appropriate graph, right? This means how do we scale a graph properly? And we'll talk about what that means just in case you don't know. And in addition to scaling, how do we actually plot points? And then ultimately, how do you set up what you want to look at? And we'll discuss all of that. Hopefully, if it's not in this video, you'll probably find it in another video that has to do specifically with graphing. I'm probably going to make one of those instead, so that way you can really see all of the different components that go into graphing, and you can make yourself a checklist to make sure that your graphs are as good as they can be. Okay? So let's get started here with some coordinate geometry. First and foremost, I'm going to go ahead and make a graph. I'm going to kind of just run through it, and we will review the different pieces that go into graphing on another video. So hopefully you'll have an opportunity to check that out. But first and foremost, you want some sort of straight edge that looks like this. And using your straight edge, you want to make two very, very straight lines. A lot of students tend to skip this piece of your graphing, and you say to yourself, you know what, my graphs are good enough. Right? You have time in the day to set up a good graph. So just take the time, find a ruler, a straight edge, a credit card for mom or dad, or something straight so that way you can use in order to make your lines straight and perpendicular to each other to ensure that you're going to start off by making a graph that is not only appropriate, but easy for you to read. The more time you take in making a good graph and the more careful you are, then the easier it will be to kind of solve for the distance and the midpoint of different things. Okay, so in this graph that I'm creating, I went ahead and I made the X and Y axis, and I'm choosing to just focus on quadrant 1. And I'm going to put a Roman numeral 1 there. For those of you that may have forgotten about what does quadrant 1 mean, take a look at the graphing video that will be posted so that way you can understand a little bit about what I'm referring to here. So in quadrant 1, we're dealing with just positive values. And in this graph, I'm going to go ahead and use on my whiteboard application, every two boxes down here, every two spaces will stand for one integer value on each of my axes. So I'm going to make sure that I'm scaling this appropriately, which means every dash in my graph is appropriately spaced, evenly spaced. In addition to incrementally, the values are increasing by the same rate, which means every space is going to represent one integer value increasing going vertically up the y-axis and horizontally across the x-axis. And then if you were to go negative for whatever reason, for depending on what kind of data you're using, you can go in the negative direction that way, along the x-axis and the y-axis, okay? So creating an appropriate graph is one of our objectives. We have set up our axes, we have scaled them, which has to do with spacing and incremental integer values. We're going to be plotting points, so that's coming up. And we're going to be setting up what we want. We'll talk more about that once we have a problem. So I'm going to go ahead and cross off this objective, create an appropriate graph. Okay, we're going to still add to this though. We're not quite done yet, but we want to make sure that we have a starting space or a starting place for us to do this. Okay. So with that, what I'm going to do is I'm actually going to slide this graph down a little bit so we have a little bit of room to see a potential question that we want to review, and then we will continue with today. So in this graph, we need to start setting up a problem. So let's think of an example and let's discover different pieces of this example that we can use to help answer some questions. Okay. First and foremost, let me make sure that this is a little bit easier for us to read and that we have some lattice points. Oh, okay. So in an example, what I'm going to end up doing is use 4 different points to help us look at a problem. Okay, and the 4 points I'm going to choose are 1, 3, 2, 5, 4, 4, and 3, 2. So let's review really quick. How do we plot a point? Because a lot of students have to have that question. It'll be in the graphing video, but just in case you forgot, a point consists of 2 numeric values. In this case, we have integer values. A point is x and y. And when we go to plot a point, we have to associate the numbers here with the horizontal axis, which is considered the x, horizontal axis, and then our vertical axis, y. And so if we want to end up plotting these points, we should be able to take each of these values one at a time and go ahead and plot them. So for the first point here, we have the value 1 comma 3, which means starting at the origin, which is 0 0, the point 0 0, we are going to go to the right 1 space, so along the x-axis 1 space, and then we're going to proceed to go vertically 3 spaces. 1, 2, 3, and we'll end up plotting a point right here. Now, what I like to do and what some teachers like to enforce is if you're learning how to do this for the first time, or maybe you don't feel comfortable doing it, label what point you're using there. So that way you remember what point you're dealing with. And if anybody's trying to refer to your work, they understand what point that you think that is. Okay, so if I quickly go ahead and go through the rest, 2, 5, I'm going to go ahead and label it. We have 4, 4. I'm going to go ahead and label it. Oh no, that looks like 9, 9. I apologize for my whiteboard application. And then ultimately 3, 2, 3, 2. We will end up seeing that we have 4 points that are here. Now, in this problem specifically, these points are going to create a square. And for this problem in particular, I'm going to tell you that it's a square. For some classes or for some problems, I will not tell you what shape you're making. It's up to you to either prove that to me just by knowing the different properties of shapes, or you can go ahead and just kind of guess what shape you're dealing with and then prove it to me later. So here I'm going to go ahead and connect all of the lines because a square is a closed shape. So all of the sides should be closed between all of the points. And knowing the different properties of a square, we can go ahead and connect all of the points and create a shape that has 4 equal sides. This is going to conclude the creation of an appropriate graph. And for some reason, my graph has fixed itself. There it goes. And so if we come back up and we review our objectives, we've created an appropriate graph. Now it's time for us to calculate the distance between points and the midpoint between 2 points. So in order to do this, let's look at some questions for this example. We'll call this question 1 or part 1, plot the points to create a square. Part 2, find the distance between the points 2, 5 and 4, 4. Now, this type of question I'm going to refer to as it's a basic question. It's very straightforward. It tells you exactly what to do, and you know exactly what points you're looking at. To make this question a little bit more either interesting or more thoughtful for you, the question could be elevated to express the following. Find the length of the sides of the square. So this type of question or problem is a little bit more in depth, right? It's a little bit more creative because it doesn't limit you into only using these 2 points. You can use any 2 points, but you need to know that you're looking for the side of the square. So the piece that this question would also elicit, just in case you're not paying attention, some students might go ahead and find the distance across the square with 2 opposite points. Okay, so the keys here is finding the lengths of the sides of the square and understanding what that is. So if I were you, I would start understanding the images that you're making on the graph, such as this square here, and the different pieces of that. So in this case, I want to find the length of the sides of the square, which means I want to be looking at any of these sides. And because I know it's a square, all of the sides are the same, and I can choose any 2 points. So for this problem, in order for me to find the distance between 2 points, in order to locate or to solve for the side of one of these of this square, what I'm going to do is I'm actually going to use the 2 points that are given to me in this basic problem. Okay. So here is the work for this. I want to look at the distance between 2, 5 and 4, 4. In order to do that, I need to know a very important formula known as the distance formula. So the distance formula can actually be derived from the Pythagorean theorem, is going to be d, actually we'll use capital D for this, equals the square root of, actually, let me go ahead and write that down here. D equals the square root of, we need to incorporate both points when we're finding the distance. So each point will be used somewhere in this formula. In order to distinguish between this point and this point, we're going to be using subscripts, which are these little numbers down here, to identify which points we're using. So in this case, we're using the x value from the second point, subtracting that by the x value of the first point, that whole quantity, the whole difference squared, and we're adding that with the y term of the second point subtracted with the y term of the first point squared. So let me go ahead and review this one more time. In this problem, to use the distance formula, we need 2 points. It seems self-explanatory, but it's important to know. We need the first point, which we can identify as x subscript 1, y subscript 1, and we can call this point 1. And we need values from a second point, the second x value and the second y value. We use these subscripts to distinguish different x terms and different y terms based off of whatever type of problem we're working with, if we're given multiple points or multiple pieces of information that could be identified with this specific variable term. So for us, we have 2 points, which means we have 2 x values. We have a value of 2 and we have a value of 4. So in this equation, we need to distinguish which one is going to be which in the problem-solving process. If you notice, we're referring to the second point first, using both of these differences within the parentheses, and then we're going to subtract that with the values of the first point. So let's see how we do this when we actually write it down. So I'm going to use this distance formula. And what I want to do first, and I recommend you do this too, so that way you don't get stuck and you can use this all the time, is I like to verify the different points that I'm working with. I like to label them. So in this point, I'm going to treat this as my first point, and I'm going to treat this 4 as my second point. Just so that way I can keep my terms orderly and I know exactly what I'm plugging in where. So just like a jigsaw puzzle, if I went ahead and I started plugging in these values, I'm going to take the square root of the difference of x2 comes first, so that's a value of 4, subtracting that with the value of 2 from the first point. I'm going to square that value, add this quantity with this other quantity, looking at the second y term and the first y term, 4 minus 5, value squared. And then I can start simplifying it so that way I can make this easier to solve. I'm going to still have the square root here. 4 minus 2 is 2. I'm going to keep the set of parentheses squared. I'm going to add that with 4 minus 5 is a value of -1 squared. And then I'm ready to start solving this. A common misconception when you use this formula is that when you have this value within the set of parentheses, -1 squared, a lot of students tend to think that this is a value of -1. They think, oh, okay, we have a negative and a 1. Well, 1 times 1 is 1, which means that's a value of -1. But in fact, whenever you square a term, what you're doing is you're taking whatever value is in that set of parentheses and you're multiplying it by itself this many times. So if we square something, we're just multiplying it by itself twice. So -1 multiplied with -1, which is going to equal a value of 1. So if we go ahead and simplify this under the set of parentheses, we'll get the square root of 2 squared. 2 times 2 is 4. We add that with what we just discussed with -1 times -1, 1. And we can simplify this to the square root of 5. Now, this answer is acceptable for me as your teacher. If you'd like to keep it that way, I don't mind. However, for some of you, you may go ahead and you can simplify this. You can use your iPhones to help you out. You can use a calculator to help you out. You'll see a button on either of them. It'll either look like this, the square root with nothing under it, or it could look like this with an X term, or your button could look like this with a 2, then the radical, and then an X term. So depending on how it looks, you can have either of these forms. Now, if you're using an iPhone, because I understand we're virtual learning, it's hard for all of us to get access. You're going to want to put 5 first and then click the button that looks like this. And you'll discover that the distance is going to equal a value of 2.236. If you end up using it on your calculator or an iPhone or something, or any other Android device or software, you'll find this. Okay. So let's kind of rewind a little bit. So I wanted you to find the distance between 2 points, 2, 5, and 4, 4. This is a basic type of question. This question may be similar on any sort of test or quiz if I just ask you to find the length of the sides of a square or the length of something, of some sort of object. And this will mean that you need to find the distance between any of the 2 points that will give you the specific length that you're referring to. In this case, I went ahead and I used the values 2, 5 and 4, 4, and I found the distance between them in order for me to determine the length of the side of a square. Okay, so with that, let's go back up. We calculated the distance between 2 points, check, check. And now we're ready to proceed with the next value, calculating the midpoint between 2 points. Okay. So in this problem, let's go ahead and talk about the midpoint. And in order to do that, let's refer to another example so we can take a look at it. And for this, I guess, example, we are actually going to be looking at the midpoint of 2 opposite corners of a shape. So same points are going to be used, but this time I want you to find the midpoint. Between, and this time we're going to use some opposite points, 1, 3, and 4, 4. Once again, this is a basic question. It tells you exactly what you need to be doing and where you need to be looking on your graph. In this case, we're going to be looking from here all the way across, and we're going to be finding the midpoint here. Now, we need to talk about a couple things because your question may not be this simple. Find the midpoint between 2 points. Your question could be, what point is in the center of the square? This one would be a little bit more creative because it requires you to use the midpoint, but you can use any method in order to solve for that. So looking at this type of question, it's a little bit more open-ended because if you had a graph or a picture that looked like this with the square, you can visualize where the center is, somewhere around there. But there's 2 ways to get there. You can either find that point by finding the midpoint distance or the midpoint of any of those 2 opposite points. Or what you could do is you can actually find what is the midpoint of one of these sides? And what is the midpoint of one of these sides? And using that information, you can see where those 2 lines kind of cross and intersect, and then determine the midpoint using that. For this specific example, we're going to go ahead and look at the midpoint between 2 points and locate where that is using the midpoint formula. Okay. So I'm going to keep the question up here. We're going to do the value. We're going to do this on this side. You don't need the graph in front of you as long as you just have 2 points, but we need to discuss what the heck is a midpoint and how do we find it. Okay. So the midpoint is actually going to be exactly what it sounds like. It's going to be the midpoint. So the midpoint is going to be a point. It's not a single value because you're going to have an x and a y term that is found in the middle between 2 points. Okay, and the midpoint actually has its own formula. And the formula for this, you have a value of x and y that you're solving for. And what you're going to be doing is you're going to be taking the average of the x terms and the average of the y terms. I don't know why my y looks a little weird, but you're going to be taking the average of the y terms. So in this specific problem, let's go ahead and use the points 1, 3 and 4, 4 to see if we can find the midpoint of them. And then we'll test it on our graph just to see if we're correct. Okay, so I'm going to go ahead and write midpoint equals, as we did before, I really like to label my points. So this will be my first point. This will be my second point. And let's see what we get. Okay, so we have x1, x2. So we're going to do 1 plus 4. Find the average of that. Comma, this is a comma in between. The averages of the y terms, so I'm going to do 3 plus 4 divided by 2. And then I can simplify this, so I get 5 over 2 and 7 over 2, which will ultimately simplify to the value of 2.5, comma, 3.5. And just like that, we have potentially found a midpoint. Now, I say potentially because we need to test this value on our bigger graph. So we'll take this point, 2.5, 3.5, and let's go see if it's roughly in the middle or in between these 2 points that we have on our graph. So what I'm going to do is I'm going to keep this green line here in between these 2 points because we want to verify that it's right there. And I'm going to take red and I'm going to go over. Remember, we want to test the point 2.5, 3.5 just to see if we're correct with the midpoint. So I'm going to go over 1, 2.5 spaces. I'm going to go up 1, 2, 3.5 spaces. And we have verified it. Yes, this is the midpoint between those two. And we have discovered the midpoint of this graph or of this line, the center of the square. Okay. So with that, those are some quick calculations. There will be some questions that may arise that will need you to use these pieces of information. So I'll do right here is I'll zoom out a little bit. Whether or not you're a part of DCP High School or another school that is around and you're using my videos for some help or assistance, please take the time to go ahead and copy this down. Take a screenshot if you need to, and I wish you the best of luck in whatever subject you're studying or whatever resources you need. And with that, I'll catch you in the next video looking specifically at circles. Catch you next time.